Okay guys, welcome to the test 5.1 reteach. So once you have completed this reteach portion, you'll be able to submit this and get another shot at test 5.1. So our first question is a factoring question, and they threw this number out in front to kind of make it tricky. So this 2 makes this problem a little bit difficult, but we're going to start by doing 2 times 6, that last number, and we're going to get 12. And I'm going to break 12 down, and it's going to add up to this 7 somehow. So what numbers can multiply to 12 but add up to 7? How about 4 and 3? Okay, and now we're going to use these 4 and 3 to help us break this down. So here we go. 2x squared plus 7x plus 6. And I'm going to take those two numbers we just came up with and split up this middle piece. 2x squared plus 4x plus 3x plus 6. And now, once I've done that, we can group these together. So grouping means grab the first two, grab the last two. Let's see what we can take out. From the first two, we're going to take out at least a 2 and an x. All right, so here we go. What do we have left? X plus 2 in that parentheses. From the second one, we're going to take out the plus 3, and we're going to have x plus 2. Notice these two parentheses have got to match. If they're not matching, something's wrong. But you see they're both x plus 2, so it looks like we're in good shape so far. Now, these guys that are by themselves, let's make them into a parentheses. 2x plus 3 and x plus 2, these guys are going to become their own parentheses as well. So the two lone pieces made up the first parentheses, and the other parentheses comes from that plus 2. So here we go. That matches up with one of my answer choices perfectly. And we get to keep rolling. So question 2 says to factor again. And this is one of the special factoring rules. You can look at page 69 for all of the factoring formulas. You can find the 3 different special case formulas there. Okay. So this looks like it'll be a cubed plus b cubed. And that formula reads as a plus b. A squared minus ab plus b squared. And all we have to do is figure out what a and b are. Well, a is pretty easy. That just looks like an x that's being cubed. 125, well, that's 5 being cubed. So a is x and b is 5. We're just going to play fill in the blank here. So x plus 5, x squared minus 5x plus 5 squared is 25. All right, so again, if you're not sure about this piece right here is 5 squared, and this piece in the middle, that was x times 5. Okay, so just some things to note. But that piece in red right there is your answer, okay, and you should be able to find that in the list. All right, number 3, let's keep on rolling with this factoring. Again, special case, you can find it on page 69. And this one looks like a squared minus b squared. A plus b, a minus b. So again, let's figure out what a and b are. Well, 4x squared, that looks like it's going to be a 2x that's being squared. And 25 is a 5. Again, all we've got to do is fill in our blanks over here. So here we go. A is 2x, and we're going to do plus 5, and 2x minus 5 to get our solution. So there you go in green, my factored out form. So question 4, factoring. And this one looks like it's going to be kind of wild because of that minus 120. That's a pretty big number. And they threw a 4 in the front. This might turn into a really ugly grouping problem. But instead, if I just said, wait a minute, let's start with the GCF, right, of 4. If I divide 4 out from here, x squared plus x minus 30, suddenly this problem is way easier. Because if I start focusing on this trinomial, negative 30 breaks down into 6 and minus 5, and this factors down to x plus 6, x minus 5, and don't forget to bring your 4 down. There you go, you're all done, right? We didn't even need to do more than that at that point. By taking out that GCF, we made this problem simplify really nicely, and negative 30 broke down into 6 and negative 5, which added up perfectly to that 1 in the middle. Okay, question 5. This is kind of like a quadratic looking problem, but not really a quadratic. But here we go. Let's use that U substitution method. You can find this on page 70 in your notes packet. So what we're going to do, we're going to start by noticing that this pattern exists. So I'm going to make this first part into x squared squared, 7x squared plus 10. And then I'm going to use this to replace x squared with u. So we've got u squared minus 7u plus 10. And boom, this is a quadratic that's actually not even super difficult to factor. Let's break down that 10. 10 turns into, how about 2 and 5? And they're both going to be negative to add up to negative 7. So easy factoring, u minus 2 times u minus 5. Boom, it's factored. But wait a minute. Remember that my problem didn't start with u, it started with x. So we're not allowed to leave it like that. Let's replace with this again. So here we go. X squared minus 2 and x squared minus 5. And if this broke down further, we might want to break it down, but we can just leave it like this. All right, let's look at question 6. And this one asks us, at x equals 4, what's the multiplicity of that root? Well, let's take a look. Here's x equals 4 right here. I'm highlighting it in yellow. And what's the multiplicity of that? Well, let's think about it. What shape does this make? Hopefully you're going to tell me that this makes the wiggle shape. And the wiggle shape is always a multiplicity of 3. Okay? And the other shapes, remember, are the bounce shape, which gives me a multiplicity of 2, or the straight through shape, which is going to be a multiplicity of 1. Okay, you can find all of this information on pages, I believe, 79 and 80 in your book. Okay, so in this case, we realize this is the wiggle shape, right? And so this one, the answer should be a multiplicity of 3 for this problem, okay? So all you needed to do for this was match up the 0 that we were talking about with one of these 3 shapes, and it would have either been 1, 2, or 3 as your answer. Okay, so for question 7, we've got a identifying end behavior question. So let's translate this into more easy to read terms. So as x approaches negative infinity. So if we look at the x-axis, negative infinity is going to be on the left. So as I'm going to the left, which way is my graph going? Well, very simply, we can see that your graph arrow is pointing down. So f of x seems to be going towards negative infinity. And that's all there was to it, right? Left-hand side of the graph is going down. Boom, it's going towards negative infinity. If it's going up, you're going towards positive infinity. Let's look at this graph for question 8, and we're going to look at what's the lowest multiplicity for x equals negative 3. So this is very similar to question 6. Okay, so remember, this graph is going to make a bounce, and that means what's my multiplicity? Remember, the bounce shape is going to be a multiplicity of 2. Okay, and you can find all of those values on the previous example on question 6 or on page 80 of your notes. All right, let's write another multiplicity question. So let's take a look at 3. This should be pretty familiar to you guys at this point. It's just another bounce, right? So what's the multiplicity for a bounce? That's going to equal 2. Okay. If I had picked, so this is at 3. Let's say I had picked -4 as my question. -4, it looks like I'm going straight. The answer for that one would have been 1. Let me ask you a different question. What about if I had said -2? What shape is it making at -2? That's again straight through that point. And that means it's a multiplicity of 1. Okay? There's only 3 possible answers to these multiplicity questions, 1, 2, or 3. And it's always just based on the shape. Okay? Let's identify this polynomial. Okay? So how do we identify a polynomial? We need to give it a name based on its degree and the number of terms. So let's figure out what those are first. Based on this 4, it looks like I have a degree of 4. And let's count up our terms. 1, 2, 3, 4. No like terms for me to combine, so no need to simplify. We're going to have 4 terms as well. So what do I call something with a degree of 4? That is quartic. And 4 terms is a polynomial. Where can you find this information? All of this is located on page 85 in your notes. There's a handy table where we filled in all the names for you. Okay, let's do the same thing again. This time take a second, try to find that degree in the number of terms yourself. Okay, hopefully you got that the degree is 3 because of this exponent, and there are 2 terms here, which makes this a cubic binomial. All right, let's find the vertex of the given quadratic. So finding the vertex is pretty simple. We're going to rely on -b over 2a to help us find that x value. So here we go. A is 2, b is -12, c is going to be 3, in order, of course. And let's set up our equation here, our formula. -12 divided by 2 times 2, or 12 divided by 4, which is going to be 3. Okay, be careful, guys. You do have to multiply this together before you divide. Your calculator has this tendency to put -12 divided by 2 and then multiply that 2 at the end, and you would get a different answer, and it would not be good. Okay, so this is the x value. All right, let's just note this is the x. Now, how am I going to get the y? We're going to take this number and we're going to plug it back in to get the y value. So here we go. 3 squared minus 12 times 3 plus 3. And I'll just highlight this that we plugged it in. So we're going to get from here, if we either punch this in our calculator or if we decided to do it by hand, we should get that this is -15, and this is going to be my y value. So now we've got the x value and the y value, and these make up a 0.3 comma -15, and that is my vertex. Okay, so get the x value using -b over 2a, and then you can get the vertex by plugging that number back into your formula. All right. Now, last one, we want to write a polynomial based on the information that they've given us. They've given us some zeros and their multiplicities. So let's try and put this together. So each different zero is going to give me a factor. So this first one, -2, 0. Remember, it's always got that sign flipped. So here we go. This is going to give me x plus 2. 3, 0 is going to be x minus 3. And 4, 0 is going to be x minus 4. Always got that sign flipped. Well, what other information do I need to use still? Well, the multiplicities are still there for me. right? 2, 1, and 5. And each of those is going to be the exponent on these pieces. So that negative 2, 0 came from x plus 2, and that's going to end up being squared. The second one is to the first power, and the third one is going to be to the fifth power. So we should end up with 2 to the squared, 1, and 5. And remember, we don't really need to write the 1. So we'll discover that this first answer choice is the correct one for us. Okay, guys, that's it for this reteach portion. As you can see, a lot of these graph questions and the polynomials questions were not very difficult. You really could have very quickly made it through those. Make sure that you have practiced factoring, guys. That's going to be the big thing that holds you back otherwise. All right, good luck, happy studying, and make sure that you get that reassessment in.